Hello, Internet, and thank you very much for tuning in to the Cloud Native Islamabad YouTube channel. I am the co founder of Cloud Native Islamabad's community, and I believe today is a flood of audience will appear because the topic we're talking about is very interest to you. So, let me give you some high level overview of what we're talking about. Today is all about Argo Workflow. Argo Workflow is an open source container native workflow engine for orchestrating parallel jobs on Kubernetes. It is designed to run series of containers and perform computation in a distributed and scalable manner. Argo Workflow helps streamline the process of managing complex workflow and enables automation of critical business processes. So Argo Workflow, which is based on the successful delivery during a client engagement. So I will state go to co-founder of this projects, maintainer of the Argo projects, Zubair and Zach Aller for the introduction, and then we start the proceeding. So Zach, can you introduce yourself to our audience today?
Yep. So my name is Zach. I have been doing software development / SRE type platform work for the last, I don't know, 15 years or so. I recently started working at Intuit, where I have become the lead maintainer for the Argo Rollouts project. It's been an interesting experience working on open source. It's a lot of my past history has come from working on internal systems, and it's been an enjoyment to kind of lead a project. So it's been an exciting time for me.
Thank you very much, Zach. And now over to Zubair. Can you introduce yourself?
Hi, how's it going, guys? My name is Zubair, currently a senior SRE at CCRI. I have about 12 years of experience focusing on automated infrastructure and cloud deployments, microservices, API development, CI/CD pipelines, solution architecture for cloud deployments. Fun fact, I used to work with Zach and Michael, so this is good to be here and talk about Argo rollouts and progressive delivery.
Thank you very much. And we have a good audience. I can see it on the studio as well. So over to you. I will be disappearing from the screen, and Zach and Zubair will be taking the charge. And let me know. I can share the screen now. And over to you both, Zubair, and to start the proceeding.
Sure.
All right. So I'm gonna start off a little bit and kind of give kind of a high level overview of what Argo Rollouts is. Argo Rollouts is what I would call a progressive delivery controller. For those that aren't familiar with progressive delivery, the idea is that when you deploy a new version of software, you want to do that in the safest way possible. And in order to do that, there's a handful of different ways. You generally will hear of different strategies such as blue-green or Canary deployments. Those are kind of the two major ones that Argo Rollout supports. They each have kind of their pros and cons of when you would want to use one over the other. Blue-green generally gets thought of as, you have version 2, you're running version 1, you want to do version 2. You set up kind of like a preview environment for that version that lets you as a developer either manually test that or write some automated test against the new version before making that switch at the end to make that version live, and doing that in kind of an automated way. As far as Canary deployments, canarying is, and what we're going to be demoing today is Canary deployments. It does the same thing, but instead of, I guess, either manually testing or automatically testing the preview version, it lets you control traffic. So you could say send 10% of your traffic to the new version over some period of time, an hour, 30 minutes, etc., and baby step up how much traffic gets sent to the new version. And then the Argo Rollout controller gives you the ability to run what we call analysis runs during this whole deployment cycle, which can look for things like error rates, any type of custom metric. Basically, the analysis system lets you query various metric providers or anything like that. And if it detects an error, can abort that rollout. So yeah, that's kind of what we'll be talking about or demoing a bit. I'll pass it off to Zubair, and he will kind of go through a walkthrough of how you can set this up on your local machine and kind of play around with Argo Rollouts.
All right, so for today's demo, we're going to be going over a Canary rollout strategy where we're going to use Argo Rollouts to release our application. But when we're releasing our application, we're only going to promote it to a subset of our users. We're also going to demo how to do an automated rollback using the analysis template on the Rollouts dashboard. We're going to be doing all of this locally on Docker desktop. I'm going to start going over everything we need. And before I get into all of that, you can follow along with this workshop by using this README here. This is also the Argo CD Rollouts workshop that was in ArgoCon 2022. And today we're going to be demoing exercise 3 and 4. And we're going to start by setting up our local cluster. So I'm going to go here to the command line. And the first thing we're going to do is we're going to create an Argo CD namespace. So we use the kubectl command to do that. Okay, the output confirms everything was successful and that the new namespace has been created in our local Kubernetes cluster. Now we're going to go ahead and install Argo CD in our new namespace. And that's where all of our Argo CD services and application resources are going to live. So I'm going to do that right now. Okay, now here's a brief synopsis of what is actually installed here. We've now installed all of the necessary CRDs that Argo CD needs. We also have the various service accounts that Argo CD needs for all of our Argo CD components, which includes the application set controller, the notifications controller, and much more. We have cluster level permissions such as roles and cluster roles. These roles will be providing the permissions needed by Argo CD to interact with all of the various resources in our Kubernetes cluster, allowing us to ultimately perform the various options needed for today's workshop. We also have the role bindings and the cluster role bindings, which will associate the service accounts I mentioned with their respective role and cluster role. We've got our config maps, which is the config data for our Argo CD components. We have all of our secrets, which is storing the sensitive information such as API keys, credentials, and things that help our cluster operate. Then we have deployments and stateful sets, which are composed of running instances of specific Argo CD components that will be used for this workshop. And finally, the network policies, establishing the specific network connectivity rules for Argo CD, ensuring that we have secure communication within our Kubernetes cluster. So now that we have Argo CD up and running, let's check the status of everything real quick. Okay, so now this command is going to provide us with the insights in regards to the health of our installation. So we have our Argo CD namespace, and we have the following pods up and running. We have the application controller, the application set controller, the Argo CD DEX server, and the notifications controller, Argo CD Redis, and the repo server pods are all up and running. We also have core DNS, etcd, Docker desktop, Kube API server, Kube controller, and the Kube scheduler. Now, so the next set of commands we're going to run will utilize the Argo CD CLI. I've actually already installed that CLI, and it's a part of the workshop prerequisites, the README I just showed earlier. So before we get into the CLI commands, we're going to need to retrieve the admin password for Argo CD. The command we're about to run is fetching the admin password that is stored in the Argo CD admin secret, which lives in our Argo CD namespace. The secret is going to get decoded, which is going to allow us to interact with the CLI and the Argo CD API. Put that right here. Okay, so I'm going to take this and store this in my notepad real quick. Okay, so now we're going to use the Argo CD login command to log into Argo CD. This is where we're going to need the password that we just had. I'm going to go grab that real quick. Okay, we've logged in successfully. So we're now going to add a repo, which will be a part of our Argo CD list of managed applications. Okay, the repo has been added. So just to reiterate here, this is the same repo we specified as our workshop project with the README I just showed. The next thing we're going to do is create an app using the Argo CD app create command. Okay, this command is creating an application for the Argo Rollouts controller in Argo CD. Now we're going to sync this application. Okay, so that command is basically asking the API server to sync our Argo Rollouts application. The application controller is going to be scanning the state of the resources and then apply them to our local Kubernetes cluster. The command then watches for the sync operation and reconciles the state. Whether it's a fail or success, we have now synced and applied the namespace, the service account, the Argo Rollouts notification secret, the cluster role, which is going to allow Argo Rollouts to view, edit, and modify resources in our Argo Rollouts app, and the CRDs, analysis templates, experiments, and rollouts. We're also going to be using Istio in this demo for traffic routing for our Canary deployments. We're going to go over in a bit how we're going to have granular control over the traffic percentages that we release gradually. We're going to be gradually diverting a portion of the traffic to the Canary pods while monitoring their performance with Prometheus. So let's start off by installing the Istio Okay, and then we're going to export this path right here. Okay. Now we're going to do the default installation of Istio with their CLI tool. Let me see, because Istio control set profile.
I think you're missing the version.
The version. Do we have that command before?
Yeah, it's just the tag. CTL.
Do you have the tag version command?
I'm looking for it. Where did I send that to you? I'll grab it from the link.
Oh, right here, the global tag.
Yeah. Yep.
Let me just grab that real quick.
Copy that. Yep. So you actually had a space between your double dashes and set. That's why that didn't work without the tag.
Oh, okay. Okay, so now once this command is run successfully, we have now installed Istio. It's complete. The core components are Istio-D, better known as the Istio control plane, the egress gateways, and the ingress gateways. So now I'm going to create a new namespace called Argo Rollouts Istio by using the kubectl create namespace command. Okay, the namespace is created. We need to enable the Istio automatic sidecar injection into our new Argo Rollouts Istio namespace so it can be used by our application. Find that command real quick. Oh, was it here? There it is. Okay, it's labeled. And now we're going to set up Prometheus for monitoring our local cluster. The command that I'm about to run is going to set up Prometheus and its relevant CRDs in our cluster. Okay, we're now going to configure Prometheus along with all of the related components we need to monitor our cluster, like Grafana, Kube State Metrics, the node exporter, and the Prometheus adapter. Okay, these components are going to work together to gather the metrics and insights from our Kubernetes cluster, providing us real-time monitoring and visualization of its health and performance. These days, someone would say this is the de facto standard for monitoring. You can gain valuable insights and make informed decisions in regards to your infrastructure, so you can keep things running smoothly or whatnot. So let me go ahead and bring up Visual Studio Code now. We'll go over okay. Okay, so now we're going to go over how we're going to use Customize to build and orchestrate a controlled Canary rollout strategy. In this file, we're going to have two mirrored services, the Istio host split Canary service and the Istio host split stable service. Both services are copies of each other and receive the same traffic. However, during the Canary release process, the traffic distribution between the two services will be controlled by the rollouts object and the Istio virtual service, allowing us to gradually shift the traffic to the new version while monitoring its performance before promoting it to receive the full traffic. We're going to do that with set wait, and Zach's going to go over that in a little bit. So here is the Istio host split Canary service right here. I'm highlighting it, which is the service that will be mirrored to the Canary service below, which is the split stable service. The metadata has the names and labels for the service, which is going to be listening in on port 80. And we'll be forwarding traffics to the pods that are labeled Istio host split. Okay. Now, right below that, we have the split stable service right here. Like the previous one, it's also responsible for handling the incoming traffic. It's going to be listening in on port 80 as well, and it will forward the requests to the pods that have the same label. Now, something we want to notice is that the rollouts controller will add a hash to each service, which will be labeling it for us. It will allow the rollout to differentiate which pod is which when it's doing the Canary rollout. That's going to be happening with the rollouts pod template hash field. The Istio host split stable service represents the stable version of our application. We both services are mirrored, working together. We can seamlessly manage the traffic distribution and achieve smooth application deployments. So underneath the stable service, we have this virtual service right here, which I'm going to highlight. And this is responsible for managing how incoming traffic is routed and distributed between our Canary and stable services. Let's break down the key components. So we have spec, which contains the detailed specification of the virtual service object. The host field is where we're going to define the host for the virtual service. Using the star here, it means that the virtual service is configured to match any host. And it's going to be able to allow all incoming requests regardless of the host header value. The gateway field is determined in the Istio gateway, which will be used for our virtual service. And you can see it's connected to the Istio host split gateway. The HTTP section is where the route rules are defined for incoming requests. We also have a name field, which is used to give a label to the route. In this case, it's labeled as primary. And then we have the destination field, which allows us to specify where the traffic will be forwarded. In this case, it points to Istio host split label stable service with a weight of 100. The weight represents the percentage of traffic that will be directed to the stable service. Then we have the destination field, which is set to the Canary service. It currently has the weight of 0. This means that no traffic will be sent to the Canary service initially. So let's start going over the gateway object here. Okay, the spec here is the spec has a selector, which is the Ingress gateway. This is the Istio default controller Ingress gateway. The service field below says it's listening in on port 80, and on the bottom, the host is set to star, meaning that this gateway object will be able to match any of the hosts for all the incoming requests. So what all of this means is the virtual service above is responsible for controlling all of the HTTP requests, and the gateway object is making sure that the virtual service is accessible to all external traffic. When a request comes in through the gateway, the virtual service will be handling all of that routing logic, directing traffic to either the Canary or stable service. And that weight is specified in the virtual service route rules. Now I'm going to scroll up here and I'm going to let Zach go over the rollout object.
So the rollout object itself, you can think of as the way that we're going to configure the controller to basically manage the deployment. The rollout spec is pretty much a drop-in replacement for the deployment type than the native Kubernetes deployment type. You see where, can you scroll down just a tiny bit, Zubair?
Yeah, sure.
Just the first. We're gonna look a little bit more. We're like lines, yeah. So lines 92, that is the template of the pod spec. So in the deployment object, you generally have a template as well that defines the pod spec. You literally import, you could copy and paste your deployment template, drop it into the rollouts configuration, and apply it, and it would run. All the stuff up above from lines 92. Now, if you scroll back up to the top, is kind of the rollout specific configuration. So, yeah, right here, cool. So we have simple stuff like a replicas, start with 4 pods, and then the strategy that we're going to use. This is where you'll be able to specify whether it's blue, green, or canary, etc. Any type of analysis you want to run. If it's going to be a background analysis, it will live here. So as you can see, we're going to be using the Canary strategy. This is configured to run an analysis step called success rate analysis template, which we'll talk about a bit later. And it's going to start at step 3 within our defined steps, which we'll talk about down below. Argo Rollouts does allow you to pass what we'll call like parameters or variables into your analysis templates. So in this particular case, it looks we are passing basically a variable called service name with the value of Istio host split canary, which will allow us to query in this particular case, Prometheus, to grab error rates of that particular service. You can pass in any defined variables. You can actually look into the rollout spec itself and grab particular fields that you need or would like to, and pass those into the analysis template, which I'll show you how that works in a minute. Lines 68 and 69 are just telling the rollout controller which two services to use for the Canary and stable service, which it will then apply those selector labels on so that each service matches the particular pods that it's supposed to, such as the Canary pod or the stable pod. The next section is where we just configure, we basically tell it that we're going to be using Istio. Argo Rollouts supports a whole bunch of different traffic routers. You can also do canarying without a traffic router, which we would call like a basic canary, or I call it a basic canary, which just uses pod counts. So you have 10 pods, you do, 20%, rollouts will just split. It'll tear down 2 pods on the stable, put 2 pods on the canary, and then it just depends on Kubernetes traffic routing to get that percentage. So you can basically use rollouts without having to go through the extra work of using a traffic router. However, by using a traffic router, you do gain some extra features, we'll call it, that lets you do things that I'll explain down below in the steps. So the steps here are kind of, the core of why people generally tend to want to use rollouts. I think, so when we're deploying a new version here, and we're on version 1 and we go to version 2, I'll define a couple of these steps, and there's some more steps that rollout supports, but I think these kind of give you a good basis starting point. Because we're using a traffic router, we have the ability, actually, which I think is kind of a really neat feature within rollouts, is we have the ability to control pod counts being separate from traffic percentages. So this first particular step here, set Canary scale, actually spins up 25% of the pods on the Canary without sending any traffic to it yet. So I kind of like to call this like a blue-green canary, because it gives you kind of a blue-green step in the beginning, but then later falls down into the normal canarying stuff where you'll start shifting traffic weights. This is kind of a nice feature. We actually use this a bit at Intuit as well. It lets people do kind of like a test, an automated test against those pods without sending any traffic to them yet. And then the next step is pause. So we basically spun up 25% of the pods, and then we're going to pause indefinitely. So that there's no duration defined on this pause. So it'll pause forever until you can either use the CLI or Argo CD to basically promote. And then set Canary scale, match traffic weight is just a little behavior change of set weight. There's some documentation on that on rollouts, on the Argo Rollouts website. It basically controls how set weight works. So on lines 82, we have set weight, which will by default control pod counts and traffic weights. However, because we use set Canary scale, the first time you use set Canary scale, it turns off that default behavior to kind of like disjoint them so that pod counts are separated from traffic weight. Lines 81 or 80 and 81, that basically turn that default back on. And then we just continue through the rollout. So basically, we're gonna set traffic to 25, pause, forever. We'll promote. We'll show a demo of this as we go on, and then just go through these steps. At the end, we're gonna pause for a single minute, and then once that completes, we will, the rollout will be successful. Yeah. So Zubair, do you want to go work on setting up the demo?
Sure. So now I'm going to use Customize to build everything.
So this first demo here is just a basic, it's a traffic routed Canary, but without analysis.
Right. I'll launch the Rollouts dashboard. Take this URL right here.
Cool. So
bigger. this. There we go.
They both running?
Yep, it's running right here.
Cool. So I'll explain a little bit about what these two things are. So on the left with all the blue dots, this is kind of just a demo app that we use a lot within Rollouts to just kind of show visually what's happening. And it's just a small API that basically returns a particular color and a cell. So that there's various images that have colors red, blue, green, etc. And as we start rolling this out, you'll see that these colors will change based on the percentage of traffic. The screen on the right is the Argo Rollouts, just call it UI. It kind of gives a visual representation of the current state of the rollout. You'll see here that we're on revision 1, which is the blue pod. We got those 4 green checkboxes down the bottom. Those are basically the number of pods. And then we have the defined steps of the rollout on the right-hand side there, which we kind of looked at. These are the same steps that we looked at when we talked about the YAML, where we have, Canary scale, pause, etc., in the set weights. So Zubair, if you want to go and change the image to a new color?
Yeah. Should I do green or yellow?
Whatever you feel like.
Well, I'll be prompted to save. It'll ask me if I'm sure.
So as you can see, we've spun up a Canary pod. If you remember the YAML, because we're using a traffic router, we have it set up so that we can spin up pods without shifting traffic yet. So we have this single pod spun up, which is 25%. It's not receiving traffic. At this particular time, we could run some integration test, do some type of automated testing, manually poke around at this Canary before continuing. At this particular time within the UI, you can also do this via the Argo Rollout CLI, but you can hit promote there. And this is just going to basically unpause it or move it one step forward. So now you can see that we've actually gone and we've set 25% of the traffic to go to the yellow pod. And we've paused indefinitely, which is great. And this is reflected over in the demo app by the yellow boxes that have now started to show up. Now we will promote again, and you'll see that the pod count is, you can promote again. So now we're going to be at 50%. So we should spin up 2 pods, which we have done. As you can see in revision 2, there's now 2 green boxes, and there's 4 check boxes on the stable. And we should, now be sending 50% of traffic to the new version with 50% of the pods. And then the last one is is there a promote at the, okay. So promote again, we'll go over to 75%. And it'll do the same thing. You can watch it shift over to 75%. And now we're going to pause for 1 minute. So a lot of times people don't have a whole lot of indefinite pauses. I would say you do, you pause for some time period, etc. So once this, you can, this 1 minute would basically time out, but we won't wait for it in this particular case. If you just want to go and either promote full. So what promote full will do that's different from promote is that if you, let's say you're in the middle somewhere and you have an analysis or you want to promote no matter what, promote full does that. It basically overrides all the steps. It'll skip everything and make yellow the stable. So yeah, you can do that. And so as you can see, yellow should be at 100% traffic now. There's a timer that starts, and this is a configurable value. You can see that on revision 1, those pods are going to stay around for 18 seconds there, 16. So that will count down. Once that times out, which is defaulted to 30 seconds, it'll start tearing down the old stable, which is good. So that was just a basic non-analysis templated rollout. Generally, people want to do things a little more exciting than that, and they want to have some query run, some type of background analysis. You can spin up jobs to do that. We actually have a plugin system that you can write metric providers for that would allow you to have some, plug in, run, and do things to validate that things are correct, that you can use as analysis. And then there's also the ability to just manually roll back. So as you can see on revision 1 there's a rollback button as well. And you can use that to basically do a manual rollback, which you can now click, Zubair. And we'll just show that as well. So it basically switched everything back. It should, in theory, start shifting traffic. We missed it. That is the, sorry. Because we did this after a full promote, it actually started a new rollout. It would have to happen within the defined 30-second window to be what's called like a fast track rollback. And there's some settings you can control there, but because we waited after, it's basically kind of like a roll forward. So if you scroll up, Zubair, you'll see that we're sitting on in the steps. If you go to the steps and scroll up in the steps,
right,
we basically started a new rollout going back to blue.
Oh yeah, I see that right here.
It wasn't fast tracked because we had successfully marked yellow as stable. So now you can just do a promote full, which should then basically skip all the steps and immediately get blue to go to 100% traffic. Now let's quickly look at a little bit more interesting example, and we're going to go inspect what the analysis version looks like. And we'll go look at an analysis template as well. If you want, Zubair, can you, just install the analysis template one? Yeah, perfect. And then let's go look at the manifest for the analysis template itself.
Right, let me pull that up.
So this particular analysis template ends up being just a Prometheus query. What we're doing here is we're going to query Prometheus, and we're basically going to get a success rate. We're going to look at the request total with 500s divided by the total rate, or the total Istio request. And we're using an Istio metric to do this. You could provide any metric that you wanted within Prometheus in this particular case, and get some results. We're looking for some success condition. In this case, the online's 14, the result being greater than 95%. We're going to run this query. The interval there is every 10 seconds. We're going to run it 15 times. This could be also 0, which would make it indefinite. But now let's go back to the...
One thing I wanted to point out is the Prometheus provider is allowing you to use PromQL, which is the Prometheus query language here. So this is a big deal right here, lines 19 and 21, 19 to 22. So...
And you can, the plugin system I was talking about earlier allows you to also do a plugin as an analysis template. So you can run some Go code that does whatever it needs to do. You can also spin up jobs. There's a whole slew of providers. But now that this is deployed, we made the change. You can see that we're actually sitting currently trying to go to the green pod.
Right.
And this green pod is going to use analysis template. So if you want to hit promote here, you'll see that analysis started to run on the bottom of the UI there, which means that we're going to start looking for error rates of the green service. Looks like we might have ran into a issue with our demo, but you see that it failed.
Right.
And so in this particular case, it automatically rolled back and didn't allow the green to basically aborted the rollout. So you can do various things like that to help, prevent outages, right? Basically reduce your mean time to recovery. You'll see it aborted the rollout, and it's going to tear down the Canary, and we're back on the stable. So everything there is good. And that's kind of the, the high level gist of Argo Rollouts. There are other features that are supported, like experiments for doing kind of A/B testing and various things like that, that allows you to do. So yeah, it's a pretty powerful system that I think is gaining some traction. You know, the whole progressive delivery space is kind of new, but it is powerful. There's a whole bunch of docs that Zubair has up here for some of the features, such as, you know, doing notifications when things abort is all supported. It uses the same notification engine that Argo CD uses. So if people are familiar with kind of how that works, they can do that. Like I said, we have experiments, analysis, and traffic management. That's kind of the high level gist of what Argo Rollouts is.
Okay, I'm going to give it back to Simon now.
Thanks, Zubair, and thanks, Zach, for the wonderful intro. One thing I like about the demo is actually the way you actually presented the Canary rollout. It's been incredibly useful today, because sometimes it's feel very intimidating how to tell people how the Canary rollout works and how the things works. So there are a few questions I have in my mind. Number one is, I think, like you spoke about, like people using HPA, VPA for these kind of activities. So and projects like CADA. So can we actually integrate CADA in somehow with Argo rollout to those kind of specific
Yes.
requirement?
So Argo Rollouts does currently fully work with HPAs. It doesn't affect like and there's some documentation on it as well. It will do the correct thing as far as scaling the stable service and then keeping the Canary service scaled with the stable service when it changes. So if CADA or the HPA tells, you know, your stable service to run 10 pods, when it's doing a rollout, it will do the correct thing and make sure that the percentage that you set to your Canary matches the current state of what the HPA is instructing the replica set to do. So just for a little bit of implementation details, Argo Rollouts controller itself just creates replica sets and manages replica sets. So anything that would work with the normal replica set, like the HPA, still does work.
Super. That's great info for me as well. And also, like, sometime, and I think you have mentioned during the workshop as well, but I want to know, like, you can shed more light into it, because sometimes there's a scenarios where you want to do a Canary rollout in particular to some event.
Sure.
Something broken, something issue occur, some error generated in the Slack channel, and you see, oh, haven't updated this manifest, and then an error appear on the Slack channel, and some third party tooling is appearing, and then you want, oh, I got the error, now I want to do a Canary roll back or roll out to the new release it. So how these things integrate with current flow?
So Rollouts only supports the idea of automated rollback during the middle of a rollout. So if you're at steady state and you're not in the middle of a deployment, doing a rollback automatically isn't within Rollout's purview per se. You could have some external monitoring system basically call either the rollback API or basically, you know, go through Argo CD and do the rollback there. I said that generally tends to fall outside of the realms of where Rollouts currently, at least, is for rollbacks. But if in the middle of a deployment, you know, you're rolling something out and some error rate increased or some other, you know, you can do, there's a whole bunch of systems that you are allowed to plug into for analysis, right? You could query internal systems, you could query monitoring systems, you could do whatever you needed to do to monitor that deployment process and then make some informed decision on whether or not you should abort that particular rollout. And I think that's where more of the strong suit sits within Rollouts currently.
Yes, absolutely. And another question, I think that's very obvious for a lot of the cloud people working on AWS, EKS, GKE. If they want to leverage rollout, and currently I think the Azure supported Flux as I think the GitOps tooling. But if they want to do a rollout, how this flow works actually, if they go into the marketplace and then install Argo Rollout and then start working on it, or is it Or is it they're installing EKS cluster first and then installing Argo Flow
Yeah.
workflow by hand and then deploying applications?
Yeah. So Argo Rollouts does require Kubernetes as a underlying system. So you do have to have a Kubernetes cluster running somewhere. And then all you really have to do from that particular step is install the rollouts controller, which will give you the rollout CRD, the analysis template CRD, and the experiment CRD, which will then allow you to use those CRDs as drop-in replacements for your current deployments. There is a feature in rollout that allows you to transition from a deployment to a rollout object and or just reference a deployment. So we put in the example that we did here, we pulled the whole pod spec and we put it into the rollout object itself. There's a feature in rollouts that is like workload reference, and you can just reference a deployment and then set the replicas in the deployment to 0, and the controller will pull that pod spec kind of in automatically for you. So that's kind of your transition path if you have a whole bunch of deployments and you don't really want to, switch them to proper rollouts. You can use those features to do that. But yeah, as far as the baseline system, you do need a Kubernetes cluster.
Yes, absolutely. And I think and I think the last question from my side is number one, people wanted to know why to run workflows on Kubernetes. What sort of advantage do we get while running your work or CI/CD pipeline on a Kubernetes-based system like Argo Workflow? What sort of an advantages?
Well, so I think you get a lot of advantage. So this is kind of more just a generic Kubernetes question, but what Kubernetes can buy you is that declarative API, right? Kubernetes itself is just this giant API system around a process that is eventually consistent of the whole operator pattern, right? Where it gives you a really easy way to get into GitOps and allows things to communicate with each other and provide a way to get, define your state in Git and let Kubernetes do the hard work, and all the controllers and operators that exist, get them into, let them take your desired state and make it a reality, right? That's kind of, I think, and as far as CI/CD, getting them all in there, the scaling, everything that Kubernetes provides you, right, is real powerful.
Absolutely. And self-healing or cluster auto-scaling, all these kind of requirement for the workflows as well in these critical time as well. And I think, and the last question is, what would you expect for Argo 1.6 coming up? I think it's in a horizon and a new particular feature that's will be interested for the community.
So the 1.6 release is, I consider, a little bit of a maintenance release. There are a couple of interesting features coming out that are a little smaller, I think. So supporting multiple ALBs. So one of the traffic routers that we get requests, and we support this with with Nginx Ingress as well, and we will in 1.6, is allowing users to define multiple ingress objects and or multiple ALBs and have the rollout controller manage the traffic using those. Where that gets used a lot is things like you have an internal and an external ingress, or an internal and an external ALB, and you want those to stay in sync. You want the percentages of traffic that are shifting to both of them to match. So that's a nice feature. The other current kind of bigger feature that we're going to use at Intuit as well is self-service notifications. So today, Rollouts doesn't let you, the only person that can configure notification support, so send a Slack message when a rollout is at step 2, or when a rollout has errored or a rollout has aborted, send a Slack message, right? Today, that configuration can only be controlled by the Argo Rollouts administrator, because the config map lives in the Argo Rollouts namespace. We're going to have a feature that allows that config map to live within the namespace of the rollout object itself. which allows a little bit more of a self-service. I as a service owner, I have access to my namespace where my rollout lives. I want notifications on a particular state. Let me configure that, right? So that'll be out in 1.6 as well. And then the last thing that it's not going to be in 1.6, but I think just a general direction that the Rollouts controller is going is plugin support. Today we have traffic router plugins, so people want to use a traffic router, they can create their own plugin for it if it doesn't exist. Same with analysis templates. And then we're looking at doing step plugins as well. So instead of just set weight, you can have custom plugins for custom steps. I think will be a real powerful feature, even though that necessarily won't be in 1.6, but it's forward looking.
Yes, absolutely. And one I think one of the things I think I see one of the blog article mentioning, you can run Argo workflows as jobs. Is it possible to run Argo flows as jobs? Like the scenario is actually the example use case can become like if somebody is actually committed or commit a new change in Git repo, and they want on every Git repo, there's a percentage of the usage actually uses the new feature. Like if somebody like Zubair or me is actually creating a pull request, commit request, and we want some job is running and it detect a new change is actually added into the repository. And then we actually say like these percentages of the user will automatically solve this application.
I'm not quite sure of the question. Is it for workflows or for rollouts or for?
Yes, like question is like is it a possibility to have a scenario where you is to run a workflow as part of the job, Kubernetes job?
So from a rollout perspective, we have the analysis template stuff that does have the ability to spin up a job as a tool to decide whether or not to abort or roll back, right? That's where jobs will come into play with Argo rollouts, which then it'll kick off the deployment and all the same stuff will happen that we just talked about. Yeah, I don't know if that answers the question, but.
Right. And previously, Zach, Michael, and I used Argo Events, the webhook sensor, to use CI/CD with Argo workflows. So we didn't have like a GitLab runner we needed to set up. We didn't need any Groovy templating for a Jenkins file. We basically just used that. And it was an event-driven architecture where people would make commits on a pull request, and the webhook and the sensor and the event bus would then dispatch it to Argo workflows to run our templated steps in YAML. So it is achievable. It's actually a talk mentioned doing that in Detroit, ArgoCon 2022. I think that Michael mentioned that. Then I did write a blog about it too. So check that out.
That ties the whole Argo ecosystem together, right? You basically have Argo events triggering things, which trigger, an Argo workflow, which then commits something to Git, which then Argo CD sees, which then Argo CD will sync, which then fires off Argo rollouts, which will then do progressive delivery. And that's kind of the whole Argo suite in a package, I guess.
Yes, absolutely. That's a brother and sister works together very wonderfully well in the Argo ecosystem as well. But thank you very much, Zubair and Zach. I think thanks for the tremendous and very well workshop and great curated demos. I really enjoy good audience. I don't know why people don't ask questions, but a bunch of very good people are watching us today. And I hope this will be a great learning resource for you because it will be recorded. It will stay in the YouTube. You can watch it later as no. So if you want to stay connected with these speakers, you go to the LinkedIn on the Zach Aller. You can connect with Zach. You can connect with Zubair. Is also the link is available on the LinkedIn. And this is a Cloud Islamabad community will do workshop. There's next one coming up on BotCube, Kubernetes troubleshooting tool. And there's a docs for Argo rollouts for all the information, very handy and very clean written and very well crafted to understand how things work. And also these are the exercise notes that Zubair and Zach uses all the information. So meaning you can do it on your home laptop or home workstation as well. With that, thank you very much. You tune into this channel, enjoy the conversation, and we look forward to your questions on the comment in the future as well. Stay safe, stay healthy. Have a wonderful day. Bye-bye, everyone.
Have a good one.